Okay, welcome. So hopefully we won't be blighted with the same streaming problems we had yesterday with things kept cutting out. I've kind of moved my computer nearer my router so that I get a better signal. My little office room here is quite a long way from my router, unfortunately. So I've kind of got a long wire going. So I can't see my own computer at the moment. So I'm going to go on YouTube on my phone, and you can see what my daughter's been watching. Okay, so I'm just going to try and find my own video. There's my channel. Not that. There we are, your channel. And then I can hopefully see. Let me just put that on. I don't know whether the normal rules about not having my phone in school apply to the situation. I guess not. I'll just see whether that text was important and maths related. No, not important. Okay. So yes, YouTube. So 3 watching, brilliant. One of those 3 will be me on this phone, but hopefully there's 2 of you out there at least, and I can kind of click on that and stream myself. A little bit of a delay there to check that that's working. That's working, isn't it? So that's good. I'm not going to use up all my data for the month. Okay, so here we go. Today we are going to look at, I'm going to continue to look at some simultaneous equations problems from the iMaths. So that's relevant to MYP3 at the moment, because I've just started you off on simultaneous equations, and I hope that the videos I've asked you to watch have made sense. And then after that, I'm going to do a little bit of trigonometry. Now that will be relevant to MYP3 soon, because it will be a unit later in the year. But then MYP4, I've also asked you to start revising trigonometry, so that's relevant to you right now. And of course, MYP5, if there's any of you watching this, trigonometry will be on the exam somewhere. I know there's a lot going on. I can see if any messages come in asking me to deal with specific questions. If you've got a specific question, you know my email address. It's jjc@the-school. You know the thing for the school. And best thing you can do, if it's from iMath, send me a screenshot of the one that you're not getting, and then I can see exactly what it is. Yeah, so send me a picture is the best way of doing that. Anyway, so simultaneous equations, and then the thing with this block of questions is that it's with decimals. So just because it's simultaneous equations doesn't mean that the answer has to be a nice, neat, round number, and often in real life situations, it's not. So 20a plus 3b equals 36 is the first equation I've got to I've got in this problem, and then 15a, I've done two different types of a's, they're supposed to be the same, plus 4b equals 34. Got a feeling the board will be too big for this, and I might have to switch to my pad. But anyway, so that's a pair of equations, simultaneous equations, and we've got to find a value of a and b that works in both equations at the same time, simultaneously. So I'm going to call those equations 1 and 2, and the thing I want to do is multiply both equations up so that they have either the same amount of a or the same amount of b. So for example, 20 and 15, well, I noticed that 20 and 15 both go into 60. So I could try and multiply the equations up so that they both have 60a in them instead of 20 and 15. I could, on the other hand, do something to make the b's the same, but I'm going to go with the a's. So I'm going to do equation 1. I'm going to multiply it by 3 so that instead of 20a, it has 60a. But then I've got to multiply everything else by 3. So instead of 3b, it's going to have 9b. And instead of 36, it's going to have 108. So I've multiplied everything in equation 1 by 3. Now I'm going to multiply everything in equation 2 by 4. So 15a times 4 gives me 60a. But then I've got to multiply everything else by 4 to maintain the balance. So 4b times 4 gives me 16b. And 34 times 4 gives me, can I do this in my head? 34, 68, 120, 136, I hope. Now, thinking about that again, yes, 136 is right. So I've got two more equations, and again, they've got to work together simultaneously as a pair, but this time they've both got the same amount of a in them. So I deliberately made that happen by multiplying up by whatever I needed to multiply up by to make the a's the same. So I'm going to call those equations 3 and 4. And because they've both got the same amount of a in them, what I can do is subtract one whole equation from the other, and then the a's will disappear. So now, because the numbers on the bottom one are bigger than the ones on the top one, what I'm going to do is equation 4 minus equation 3. So bottom minus top. So 60a minus 60a, nothing, disappears. 16b minus 9b makes 7b. And 136 minus 108 makes 28. Just checking that in my head, 28. 7b equals 28. So making the a's the same and then subtracting one equation from another, one whole equation from another, has enabled us to eliminate a from the problem. And then we've just got a simple equation that's one equation with one unknown thing. 7b equals 28. I don't want to know what 7b's are. I want to know what b is on its own. So I divide everything by 7. So I've got to divide the 28 by 7 as well. 28 divided by 7 is 4. So having divided both sides by 7, then b equals 4. Okay, so normally I'd be doing a bunch more writing, but as you can see, I've run out of board space. So what I'm going to do is kind of recycle the bit I just had. So having figured out that b is 4, just going to rub all this out. Then the next thing I would do is say I'm going to take that very first equation that I had, 20a plus 3b equals 36, and I'm going to sub in 1, which means I'm going to take the value that I've just figured out, b equals 4, and put it in that equation. So 20a plus 3b equals 36, and then the 4 that I just found out means that that equation becomes 20a plus 3 times 4 is 12 equals 36. 20a plus 12 equals 36. So we've got another equation that's just one thing in one unknown, and we can just solve that like any other equation. So 20a, I'm going to take away the 12 from both sides to get the a bit on its own. 20a equals 24. I don't want to know what 20a is. I want to know what a is on its own. So I'm going to have to divide everything by 20. So 24 divided by 20, trying to do this in my head now, is 1.2. So a is 1.2. So the values are allowed to be decimals. Okay, so we've got the solutions. A equals 1.2 and b equals 4. So problem done. But what I always like to do is check. So my next stage of my working always goes check in, not the first equation again, but the other equation that we started with, check in equation 2. Because if you made a mistake in equation 1 before, you'll probably make the same mistake again. So I like to check in the other equation. So the other equation was 15a plus 4b equals 34. And that becomes, so 15a is 15 times 1.2. Now, can I do that in my head? 18, isn't it? 18 plus, is it 18? Gosh, brain in, yes, sorry. I had a brain fail there. And then 4b becomes 4 times 4 because b is 4. So 4 times 4 is 16. And 18 plus 16 does equal 34. So we know we've got it right. Just had a a little brain fail there where I was thinking ahead and I could see it was going to be I was doing 18 plus 16 wrong in my head, and I was thinking it wasn't going to make 34, which was worrying for a second, but then it does work. Okay, so I am going to do the next one of those, I think, on my pad to give me a little bit more space. So, just dropped a load of stuff on the floor there. Okay, looking at my email, nobody's mailed me yet, so does that mean you all understand everything perfectly? Maybe it does. Okay, so here's the here's the horrible moment where I realized I've left the lid off my pen all night and it's dried out. So I think I might just pop downstairs for another pen. So I will be back in 1 minute. Okay, I can see that there's a grand total of 1 of you out there. But we'll plow on with this. So, I mean, if there is anything else you want me to do that isn't simultaneous equations and isn't trigonometry, then do send me a message. Okay, so the next one says 4m plus 10n equals 83, and 9m plus 4n equals 85. I will whiz through this one fairly quickly now, so you can always play it back and take it at your own pace. So I'm going to call those equation 1 and equation 2. 4 and 9 both go into 36. 10 and 4, well, they both go into 20. Let's try and make the ends the same this time. So I'm going to try and multiply up so that each equation has got 20n in it. So that's going to be equation 1, multiply everything by 2 to get 8m. So instead of 4m, 8m. Instead of 10n, 20n. Instead of 83, 166. And then I'm going to do equation 2 by, I'm going to have to multiply everything by 5 to make it up to 20n. So everything in equation 2 times 5. 4m times 5 is 45m. 9n times 5 is 45. 9m times 5 is 45m. 4n times 5 is 20n. And 85 times 5 is 425, I hope, off the top of my head. Okay, so that gives us another pair of equations, which I'm going to call 3 and 4. And because we multiplied up the way we did, we've made the ends the same in both. Now that we've got the same ends in both, we can subtract one whole equation from the other. I'm going to do bottom minus top in this case, just because I've got bigger numbers on the bottom. So I'm doing equation 4 minus equation 3. So 45m's take away 8m's gives me 37m's. I hope this isn't going to be too horrible. 20n, take away 20n, that's the bit that disappears. And then 425 minus 166. Okay, let's try and do that without a calculator. So it's going to be 225 plus 34. is 59. 37m equals 259. So I hope that's something that goes when I get my calculator out. So dividing everything by 37, 259 divided by, oopsie, 259 divided by 37, 7, brilliant. It goes 7 times exactly. So m is 7. So having figured out that m is 7, and if I can manage to pick up this thing, yeah. So m equals 7 is the first answer. And then I take that answer and I wonder if I can do it in a different color pen. No, stick with this. I'm just going to do a little line down there to kind of separate it off. Plus 10n equals 83. And now that I've figured out that m is 7, that becomes 4 times 7 is 28. 28 plus 10n equals 83. I'm trying to get the bit with n on its own, so I'm going to take away the 28. So 83 take away 28 is 55, I hope. 10n equals 55 by taking away 28 from both sides. I don't want to know what 10n's are. I want to know what 1n is on its own. So I'm going to divide everything by 10, left and right, and that gives me n equals 5.5. So I've got my answers, but always good practice for the last step to check in the other equation, equation 2. So equation 2 was 9m plus 4n equals 85. And then that becomes, with the values that we've worked out, so 9m, 9 times 7 is 63. And then 4n, 4 times 5.5 is 22. And 83 plus 22 is 85. So it works, and we know we've got it right. Okay, I'm going to do the... so the last one on here has got some minuses in, but with minus, it's just a case of being careful and tracking everything. I'm going to do this word problem, and then I'm going to go on to trigonometry. So this word problem says that the cost of 9 CDs and 3 DVDs is 93.45. So I'm going to represent that as an equation. 9 CDs plus 3, let's call it D, 3 DVDs is 93.45. So C here is the cost of 1 CD, and D here is the cost of 1 DVD. So 9 times the cost of a CD plus 3 times the cost of a DVD gives you 93.45, because 9 CDs and 3 DVDs costs 93.45. Well, then it tells you that the cost of 12 CDs, so 12 CDs plus 8 DVDs, so let's call that 8D, equals $158.60. So $158.60. So you can see it's given us 2 equations in 2 unknown things. So we are talking about simultaneous equations, and it's sort of messy because it's a real life problem with amounts of money. All the CDs are the same price and all the DVDs are the same price. Okay, I had assumed that, but that's not necessarily something I've got a right to assume. Okay, so I've just got 2 simultaneous equations and I'm going to solve them. So 8 and 3 both go into 24. What do 12 and 9 both go into? Let's just count some 9s. 9, 18, 27, 36. So 9 and 12 both go into 36. So let's try and multiply up both equations so that we get a 36c in both of them. So I'm going to have to multiply everything in equation 1 by 4 so that a 9c becomes a 36c. And I'm going to have to multiply everything in equation 2 by 3 so that a 12c becomes a 36c. So I'll start off with equation 1. Everything in equation 1 times 4. So 9c times 4 gives you 36. 3d times 4 is going to give me 12d. And $93.45 times 4, I think at this time of the morning, I'm going to get the calculator on that rather than struggle. $373.80. $373.80. And then I'm going to multiply everything in equation 2 by 3. So 12c times 3 gave me the 36c. 8d times 3 is going to give me 24d. And $158.60 times 3. Let's get the calculator. 158.60 times 3. 475.80. 475.80. And I put the extra 0 on there because it's money. So anyway, I've got two new equations that I'm calling 3 and 4. And because of the way I multiplied them up, they've both got the same amount of c in them, 36c. Which means if I subtract whole equations from each other, I can make the c's disappear. So again, I'm going to do the bottom minus the top just on this occasion because I happen to see that I've got bigger numbers on the bottom. So to avoid messy things with minuses, I'm going to do equation 4 minus equation 3. So that minus that. So 36c, take away 36c, cancels out. 24d minus 12d is going to give me 12d. And 475.80 minus 373.80 is giving me 102. So 12d equals 102. I don't want to know what 12d's are. I want to know what d is on its own. So I'm going to divide everything by 12, but I've got to divide the right-hand side by 12 as well. And that comes out to be 8.5, so $8.50. So in other words, $8.50 is the cost of a DVD. Okay, so having figured out what D, the cost of a DVD is, I'm now going to take that information and substitute it back into equation 1. So equation 1, as you can see here, was 9c plus 3d equals 93.45. Now that I know that the cost of a DVD is $8.50, that's going to become 9c plus, so 3d, 3 times 8.50 is 25.50. 25.50 equals, I'm desperately trying to keep my working lined up here as I always do, 93.45. That dot there is not supposed to be a recurring symbol, by the way, that's just a dot. Okay, so 9c plus 25.50 is 93.45. I'd like to get the bit with c on its own, so I'm going to take away the 25.50. But because an equation is like a balance, if I take away 25.50 from the one side, then I've got to take it away from the other side. So the 93.45 take away 25.50 is 67.95. So having taken away $25.50 from both sides, 9c equals 67.95. I don't want to know what 9c's are. I want to know what c is on its own. So I'm going to divide everything by 9. But because an equation is like a balance, I've got to do that on the other side as well. 7.55. So that gives me that the cost of a CD is 7.55, and as I saw, the cost of a DVD was 8.50. So I'm trusting that that's the answer, but, well, I'm not trusting that that's the answer, because I'm going to check it in equation 2. So original equation 2, 12C plus 8D equals 158.60. That's going to become, so now that I know what C is, 12 times C is 12 times 7.55, 90.6 or $90.60, plus then 8D, 8 times the cost of a DVD, 8 times 8.50, I can do that in my head, is 68, is supposed to equal 158.60. So $9, 90.6, $90.60 plus $68 is 158.60. Well, that is correct. So we know that we've got it right, having checked it. Okay, so that's enough with the simultaneous equations for now, and I'm going to talk about trigonometry for a bit. So as I said, this is relevant to anyone from MYP3, really. I'm just going to grab some water and see if there's anybody actually viewing out there. So I will be back in, sorry, sitting on my feet here, back in 90 seconds. Okay, so 2 of you out there at the moment. Thank you for making the effort. I'm going to talk about trigonometry now. So as I said, it's relevant. If you're in MYP 4 or 5, you've already learned this, but it's always in the exam, so it's good revision. And if you're in MYP 3, you'll be doing it soon, before the end of the year. So why not get a sneaky preview? If you do a search on my channel for trigonometry, there's 3 videos that I've made that cover everything. But let's just do a quick overview. So quick overview of trigonometry. So it's all about right-angled triangles. And in a right-angled triangle, so there's one 90-degree angle, and that 90-degree angle, that's always going to be the largest side in the triangle, because if you've only got 180 degrees in the triangle, then that one being 90 only leaves 90 degrees for the other 2. So that has to be the largest one, and the side that's opposite the largest angle is always going to be the largest side, and that has a special name. Hypotenuse. With a right angled triangle, then you ought to be immediately thinking it's either going to be trigonometry or Pythagoras. Okay, so there's usually some kind of an angle in the question. Let's pretend that that's 40 degrees, for example. So they might tell you the angle and you have to figure out some of the missing sides, or they might tell you all of the sides and you have to figure out the angle. So in relation to the 40 degrees, the angle opposite from it is called the opposite. So often op for short. Hypotenuse, I'm just going to shorten to hype for now. Let's write that up there. And then the other side, so it's next to the 40. So it's another word for next to is adjacent. So it's adjacent to the 40, but it isn't the longest one. So hypotenuse, adjacent, and opposite. So I'm going to assume that you're at the revision stage. So you've already learned about the trig ratios that are sine equals opposite over adjacent, cosine or cos for short equals adjacent over hypotenuse, and then tan equals opposite over adjacent. So if you happen to be younger than MYP4 watching this, then do a search for trigonometry on my YouTube channel, and you'll see 3 videos that explain it kind of much more slowly from the start, and then you can get an idea of what on earth I'm actually talking about here. But so this video is going to be more for just revision, and specifically for the iMaths tasks that I've set for MYP4. I'll probably check for any emails at this point, so let's just do that. Nope. Okay. So first question has got a right angled triangle, which should really be using a ruler for, but it's got an X and then a 2, which happens to be centimeters, and then it's got an angle in there of 32, and then the right angle's obviously there. Right, so the first thing we need to do is figure out what sides we have in relation to the 32. So first of all, the 2 centimeters, that's opposite the 90 degrees. So that's definitely the longest side in the triangle. That's the hypotenuse. The X is opposite the 32. So the angle that we're going to use in this problem is the 32, and the X is opposite it. So we've got the opposite and the hypotenuse. And the next thing we do is we remember our trig ratios, and then we say, okay, I've got the opposite and the hypotenuse. Is it sine, cos, or tan that has opposite and hypotenuse? So that's sine equals opposite over hypotenuse. So having identified it as a sine problem, then we stick in everything we know. So the sine of the angle 32 is equal to the opposite over the hypotenuse, and the opposite is X in this case, and the hypotenuse is 2 in this case. So sine of 32 equals X over 2. Now I'm trying to figure out what X is rather than X divided by 2. So I want to multiply that by 2 to get a whole X. But then I need to do that on the left as well. So multiplying both sides by 2 to get rid of the fraction, 2 sine 32 is equal to X. So 2 times sine 32 is X. And that's something that the calculator can just work out for us. So let me just do that. And then onto my calculator, turn it round for the scientific view. So I want 2 times sine 32. So I think this, I'm in radian mode, I noticed. So I want to get out of radian mode and put it in degree mode. Okay, so I think the iPhone calculator is one where you have to do 32 first and then press sine. But most calculators these days, you just punch in sine 32 in that order. Okay, so sine 32 is about 0.53, and that times 2 is 1.06 more or less. So x equals 1.06 to 2 decimal places. Underline answer, centimeters. And then looking at it in the context of the problem, with that being 32 and that being 2 centimeters, it doesn't seem too unreasonable that the side x should be 1.06. So always just give it a second glance and make sure that the answer you get is making sense in the real world. Okay, now the good thing about trigonometry is that there are only 6 questions, because it's either going to be sine, and then you've got to find the angle that's on the top of the fraction and then some number, or it's going to be sine where you have to but you know the length on the top and you have to figure out the length on the bottom, or it's going to be that with cos or tan. So there's only 6 different questions you can get where you're finding out the missing side. So once you got to grip with those 6 questions, then you know all of the questions. And then the other kind of thing you can get is where they tell you 2 of the sides, 5 and 3, let's say, and a right angle, and then you've got to figure out some angle that's somewhere else in the triangle. So again, there's only 3 of those you can get. So it's because that's either going to be a sine, a cos, or a tan. So in fact, there are only 9 questions in the whole of trigonometry, including 6 where you're finding missing sides and 3 where you're finding missing angles. Every other question in trigonometry is just the same question, but with different numbers in it. So if you can master 9 questions, then you've mastered the whole of trigonometry, which is a good 10% in the bank when it comes to the MYP 5 exam at the end of the year, because it's always on that exam. Okay. So I'm just sticking to the missing sides problems today. So the next problem I've got on this iMaths worksheet is, so they've drawn it this way round this time, just to make it a little bit confusing for you, with the right angle up there and an X there and a 7 centimeters there and then a 16 degrees there. I'm just going to adjust myself because I'm sitting on my feet and I've got pins and needles. Right, so this means I'm slightly lower down to the desk now, which is difficult, but first world problems, eh? Okay, so the longest side is opposite the 90 hypotenuse. This problem doesn't involve the hypotenuse because the X and the 7 are the other 2. The 7 is next to the angle we're talking about. It's next to the 16 degrees. So that's the adjacent. And then the X is opposite the 16 degrees. So we've got a triangle that where the information that we're concerned with is the opposite and adjacent. So we need to remember that the trig ratio that concerns opposite and adjacent is tan. So tan equals opposite over adjacent. And in this case, the opposite is the X and the adjacent is the 7. So tan of 16 equals x over 7. This isn't the best pen for this. It's kind of smearing, but tan 16 equals x over 7. So I don't want to know what x is. I do want to know what x is. I don't want to know what x divided by 7 is. So I'm multiplying everything by 7 to get a whole x. But then I've got to do the same on the other side as well. So 7 times tan 16 is x. And then again, that's just something I can punch into the calculator. 7 times tan 16, and it gives me a number. Shall I do it? Might as well. So 7, scientific mode. And is this going to do this for me? Possibly not. It's oh no, what's it doing? That's slightly weird. There it is. Okay, so 7 times tan 16. So on this one, I have to do the tan 16 first. 16 tan. Most calculators don't do it in that order these days. Times 7, 2. Just about 2.01. Makes sense in the context of that because 16 is actually a very small angle. So if I were to draw that accurately, then that x would look a lot smaller. Okay, so given that we've only got a couple of viewers out there, as far as I know from when I last saw, and I haven't had any email queries in, then I'm just going to do one more on this sheet, and I'm going to go for the last one. I won't bother with the ruler this time, and so I'm going to hope the last one is more challenging. It's got a 46-degree angle up there. It's got 5.6 centimeters there, and it's got x over there. So again, on this question, we've got the opposite. The x is opposite to the 46. We've got the adjacent, because the 5.6 is adjacent or next to the 46, but it's not the longest one, because the longest one, the hypotenuse, is there because it's opposite the 90-degree angle. So we've got tan again. Tan 46 equals opposite over adjacent. This is just another easy one. I was hoping this was going to be a harder one with the x on the bottom, but it isn't. So tan 46 equals x divided by 5.6. Multiply everything by 5.6 to get rid of the fraction. So 5.6 times tan 46 is x, and that's just something I can work out on the calculator again. Tan 45 is nearly 1, isn't it? So tan 45 is 1, so tan 46 isn't going to be much different from that. So this is going to come out to be quite near to 5.6 anyway. So 46 tan is just a bit more than 1, and times 5.6 is 5.79. Call that 8. So x equals 5.8 to 1 decimal place, which makes perfect sense looking at the question. Okay, I'm going to call that for a day now. I'm going to call that a day for now. I'm going to call that a day for now. And as always, do please mail me in with some questions, because otherwise I don't really know what you need the help with. And it doesn't have to be something you're currently doing. It can be just anything mathematical that's given you a problem over the, I've just realized I put Wednesday the 25th on there, isn't it? Haven't I? That's wishful thinking, isn't it? Because today is actually Tuesday the 24th. I am an idiot. What am I? Don't answer that. Okay, so back tomorrow, Wednesday the 25th at 12 o'clock.